All right, guys, we are now moving into section 1.6, solving linear inequalities. This should be a review. There's pretty much everything that we've done before as far as solving equations, very similar. The only addition is something with like graphing the domain and range and understanding when to flip the inequality symbol. Okay, so let's do this first section and then we'll go into solving. And before I go into solving, I'll talk about when we flip the inequality symbol. Okay. All right. So when we do these in words, we have x starting on the left, the example 2, x is on the right, and in example 3, x is in between two values. So we're going to put these into words. For the first one, we're going to say, instead of saying x is greater than 3, we're going to say any number that is. Okay, sorry, my handwriting is not that great. Maybe I should type it. Any number that is greater than 3. And the way we graph that is on that number line that we've kind of done in the last section. You hit 3 right in the middle, and then you make an open circle, and you shade the side that's true. If you need to, I would put some numbers on either side so you know which side's greater. Well, of course you would know this one, but I think sometimes people have trouble with negatives and numbering the side that's greater. Less negative means greater, okay? And in interval notation, how do we show that one? Well, we would put a parentheses on 3, and then what's on this far right-hand side is infinity. And a reminder again, you cannot bound infinity, so you put a parentheses on that as well. Okay. For example 2, read from this side, going that way. So you'd say any number that is, and it's pointing to the x, so that means it's smaller than 7. But then there's also that bar, which means less than or equal to. So I'm going to type that up. Let's see what that looks like if I type it up. Any number that is less than or equal to 7. A little bit better, I guess better than me writing it, yeah. All right, and then we're going to draw it. What does that look like if I draw it? Throw it up on the number line. I don't have any negatives here, so it might not be that exciting to label the sides of it, but you guys can go ahead and do that. And then we put a open circle or a closed circle. Well, closed circle means it can be 7, okay? So it can equal to 7. And then you shade the side that's true, and in this case, it's smaller, so it's going to go to the left. Okay, and on that side, we have negative infinity, so it's going to be negative infinity to 7 with a bracket on 7. Oops, let's try that again. There we go. And the last one, let's go ahead and type that one up again. Any number that is, and then you're going to read to the left and then to the right. So how is x related to negative 8? Any number that is, and it looks like it's bigger, yeah? So it's greater than negative 8. And what else? Well, it looks, how's it related to 0? Less than or equal to 0. Now let's make sure that this can fit right there. Okay. So now when we graph that, what's that going to look like? This is called a compound inequality. And you just throw these two values on your number line, and then you make your circles match. So it has to be less than negative 8. So I'm going to make a open circle at negative 8, and it can be equal to 0. So I'm going to make a closed circle at 0. And then we shade the interval in between. Now from that, you can take it directly from the number line and put it into interval notation. Negative 8 is on the left, 0 is on the right, and then we got a parentheses on the left and a bracket on the right. So another reminder, remember brackets are including and then parentheses are not including. So I did put that there in the notes. Now we're going to work on solving and then graphing and interval notation. And then just talk about some techniques. So reminder, as you learn this math, it could be review. But try to sharpen your understanding as to why those techniques are working, and then how to connect it to whatever else you understand about math, so that you're not just learning steps. Yeah, you're learning concepts, bigger ideas, and understanding just things in a bigger picture, so you're less likely to forget. Yeah. So looking at number 1, you're going to treat this inequality just like you would treat an equal sign. This inequality is just like the middle. Okay, so whatever you do to one side, you got to do to the other. Now, before I get going on this, let's talk about when does my inequality symbol flip. So I have the value 2 and I have the value 5. Which one is greater? Well, we know that 2 is greater than 5. So now, when does it flip? So some of you might know this. It's when you make the values opposite, meaning like if I change this to be a negative 2, which one is greater? Remember, which one is less negative? The 2 now is greater. Okay? So how do I make something opposite in math? Is the operation by multiplying and dividing by negative 1, by negative 1. Now, some students are like, oh, what if I add a negative? Does that change the value of my inequality symbol? Some students will just like flip it whenever they see a negative. That's not true. So if you think about the value 2 and 5, and we know that 5 is greater, and then I add, let's just add 5 to it. Okay. What do I get now? If I add 5 to both sides, I get 7 is less than 10. Is that true? Yeah, that's still true. Okay. But what if I did the same thing and I subtracted, let's just subtract more. Like instead of 5, we'll subtract 7. If I subtracted 7 to it, what do I get here is a negative 5. And on this side, I get negative 2. Which one is greater? In this case, which one is less negative? It's still that way. You see this, the inequality symbol did not flip. So the only time it flips is when I do this, when I multiply and divide by negative 1. That causes my values to switch in the positive or negative, and it doesn't just shift it. So when you add and subtract, your inequality is shifting up and down the number line. The right side is always going to be, in this case, greater than the left. So that doesn't switch, but only time you multiply and divide by negative. So let's go back to our work and make sure we just remember that one step if we do encounter that in our solving process. So if we look at number 1, you want to make your like terms combine. So I'm going to move the x to both sides I'm going to minus that 1x to the left side so that I don't have to worry about it being separated. So now I have 2 plus 2x is greater than or equal to 8. Now I have a 2-step problem to solve and get rid of the values by the x. So this is now an onion. If we can think back to what the onions did, you are just undoing. So hopefully you can pause this and just go ahead and check your answer after. Does my symbol flip? Not in this case. Okay, now just practice graphing it. Press pause if you want to just check it in the end. I'm just going to go through these problems kind of quickly and yeah, just check your work. So now if I want to write this in interval notation, I start at 3 and go to positive infinity. Okay. Number 2 is a little bit harder. We see what we despise, fractions, yeah? But notice these fractions are kind of nice. They both have 3 in the denominator. Now, if you're talking about fraction as an operation, what does that bar mean again? That bar means divide, yeah. So how do I undo division? I can multiply. So we're going to just multiply by 3 to both sides, to everything on that side. And what it does is going to clear your fraction. Okay, so let's multiply the 3 to this one. That's going to just leave me with x. And then the 3 to that one, that's going to be a minus 6. Now I got to multiply the 3 to this one. I get 3. And that one that cancels out, so it's just going to be a minus x. So now it looks like the x's are going to cancel, but be careful. We're trying to undo. So if I want to move this x to the other side, I have to add it. So now this left side is going to be x. I have 2 of them. And then I got 3. So now we're 2 steps away. So the first 2 steps are a little bit more challenging. We're 2 steps away. Go ahead and finish that and check your work with mine here. Now, it's not super nice, but you can divide that and make it a decimal. I remember somebody asking, is it okay if I make everything decimals? I don't like it when they're more than 1 or 2 decimal places, but this is a nice 1 decimal place value. So when I graph it, I know it's between 4 and 5. I'm going to put a 4.5 right here and an open circle. And it's all the values that are greater than 4.5, so it's going to go to the right. And I have positive infinity on the far right. Okay, so my interval notation is going to be 4.5 to infinity. Now, if we look at number 3, it's a little bit harder because we have denominators that are very different. And this technique I'm going to teach you right now, it's called finding the least common denominator. If you can make them all have the same denominator, you can clear your fraction. So let's look at the 9, the 3, and the 4. Now, the 9 has factors 3 and 3. So you see how this is an overlapping factor of 3? But if we look at the 4, we have factors 2 and 2 that has no overlapping factors. So really, my LCD, my least common denominator, is going to be 4 times 9, which is 36. Okay? If there's no overlapping factors, you just multiply together. But I don't have to multiply by another 3 because the 9 has a 3. Okay? All right, so if I make it all say 36, I can clear my fraction by multiplying both sides by 36. So let's go ahead and do that intermediary step by making it say 36. So the first one, I have to multiply the top and bottom by 9. Second one, I have to multiply the top and bottom by 4. And the last one, I have to multiply the top and bottom by 12. So this is going to say negative 27x over 36. And this is negative 20 over 36. And that's 12x over 36. Now we're at a place where we were in problem 2, where we can multiply everything by that denominator. When we do that, it clears that divide by 36 out. So if I multiply this side by 36, those are going to cancel. Same for this side by 36. They're going to cancel here and here. So now I just have my numerators, negative 27x and negative 20 plus 12x. Now, when can I just do that? Remember, I can do that if I have an equal sign or an inequality symbol. What I do to one side of my equal sign or my inequality symbol, I need to do to the other. Okay. Now, if it's just an expression, there's no equation, you cannot just clear flat fractions. All right. Now, at this point, I'm going to move my x's to be on the same side. So I have like 2 of these x's. Let's move that 12x by subtracting it. If you move the 27, everything would be on one side, which you would still have to move it back to the other side in general. So I'm going to move it all to this left side. It's negative 39x is greater than negative 20. And then we divide both sides by negative 39. Now, notice this is the step that we want to watch out for. What do we have to do now? I hope you remembered. X is now going to be less than. Both of these are negative, so it's going to turn into a positive 20 over 39. Okay. Now, 20 over 39, you can put it in a calculator, but just use your number sense in the sense where, what value is that close to? Well, 20 is half of 40, so 20 out of 39 is a little bit more than half. So I'm going to go and mark 0 and 1, and then that value is 20 over 39. Okay. Oh, I missed my inequality symbol. There's an equal to along the way. So now at that point, I'm going to put a closed circle, and I'm going to shade the side that's true. So all the numbers that are smaller than that, which is going to go to my left. Okay, so now I have negative infinity on this side. So in interval notation, negative infinity up to 20/39, and I'm including that value. Okay. Now, normally in class, I would just let you guys work on these problems and try, and then I'll walk around and help you. And then I would put an example of a student's work up on the board. But we don't have that luxury today. So pause and try number 4, and then press play. But I'm going to go over it right now. So if you want to watch, don't know what to do, press pause after you kind of start to know what to do. Okay? So this problem in number 4 is a little bit harder because I have lots of things going on. You can distribute that 6 and the 6x and the 2. Now don't distribute the 2 to 2 sets of parentheses, just to 1. If you do it to both, then it's actually, you're distributing a 4. Okay. So this is going to be 6x squared minus 42x. This is going to be 6x minus 2. Now that is still going to be multiplied to the 8, the x minus 8. Now, if you forget how to FOIL this out, you want to do the first, the outer, the inner, and the last. And that's going to give you your polynomial. So this is going to be 6x squared. 6x times negative 8 is negative 48x. Then we got negative 2x and plus 16. Now, it looks hard, but what's going to be nice right at this point is when we start to combine our like terms. So notice these are alike and these are alike. Okay, so let's put them together, but remember, if you're on one side of your inequality symbol, you have to undo it to put it together. So I'm going to first minus the 6x squared to both sides, but notice it becomes 0. So now I have a linear equation. I don't have a quadratic anymore, and there's no x squares, so now it's linear. Combine these two, that's negative 50x, and then I still have the plus 16, and then negative 42x. So now I'm going to move that 50x. I'm going to write that in black. So I'm hoping that you were able to finish the rest of this. I have 8x on the left, and then I have 16 on the right. It kind of comes out nice. Divide by 8. We got x is less than 2. I do not have to flip my inequality symbol because I am not dividing by a negative value. So if I want to throw this up on the number line, I have x is less than, so open circle, and on everything to the left. So interval notation, negative infinity to 2. And the last one we're going to do is a compound inequality. It's not that hard. Now, if my x is in the middle, what I do to one side, I have to do to all the other sides. Okay, so first thing we want to undo is that minus 1. And the way that you undo it is you add 1 to all 3. You're going to shift it all up by 1. So this is going to now say 2. And I got 2/3 x. And I have 10. And the next step is I want to undo that 2/3. So remember, it's multiplying by 2, dividing by 3. The way that we undo it is divide by 2 and multiply by 3. And that's by multiplying by the reciprocal. Okay? So you're really dividing by 2 and multiplying by 3. And it kind of comes out nice when you divide by 2 here. So that one comes out to be a 3. And then this side is just x, and then the last side, the 10 and the 2 cancel, so it's 5. 5 times 3 is 15. How do we graph that? If you can remember, you throw these two ends on the graph, 3 and 15. Then you look at your symbol. So can be equal to, you draw it in, and it cannot be, you make an open circle. And it's all the values in between. Now, same thing for the interval notation. You take the 3 and the 15, and you put them up there. All right, and the last thing for this section is just remembering certain things. When you're multiplying or dividing both sides of an inequality by a negative, you need to flip the inequality symbol. Okay. Now, parentheses are used with which inequality symbol? They're the ones that are not, doesn't equal, so greater than or less than. And then you use brackets with the ones that have equal to on it. And the last thing, next to the infinity or negative infinity, always use parentheses, because you cannot bound infinity. What else? You cannot bound infinity. It's not an actual value. Okay, it's the idea of where that number goes. Okay. All right, that's the end of this section of notes. I hope that you can pause and look back and hopefully learn what's going on in this section.